Hello, 5th grade. Today we will be rounding decimal numbers to the nearest whole number, which is our first objective, rounding decimal numbers to the nearest whole number. Second, we will estimate the perimeter area and volume of geometric figures. Remembering that when we estimate, we round before we use the proper formula for perimeter area and volume. If you turn your books to page 679, that's where this lesson 104 begins. It says the new concept is in previous problem sets we have answered questions such as the following. Is $7.56 closer to $7 or $8? Okay, $7.56. When we answer this question, we are rounding $7.56 to the nearest dollar. This is an example of rounding a decimal number to the nearest decimal or to the nearest whole number. Using rounded numbers helps us to estimate. A number written with digits after the decimal point is not a whole number. Okay, so whole numbers, remember, 1, 7, 94, 62. Okay, those are all whole numbers. Numbers that are not whole numbers, numbers with any decimal. Okay, this is 5 and 7/10. It's not a full 5 or it's not a full 6. It has 5 wholes and then 7/10 of a whole. You can also, numbers that aren't whole numbers can also be written as mixed numbers, such as fractions, such as the fraction 5 and 7/8. Okay, these are whole numbers. These are, of course, not whole numbers. Okay, and then they show the decimal. They show a number line. Okay, with numbers with the numbers 7 and 8 labeled. They show 7.5, also known as 7.5, of course. And we know that $7.56 is somewhere in this area. Is it closer to $8 or $7? Well, it's on the right side of 7.5 or 7 5/10. So it is closer to $8. So we basically did rounding. It's just we haven't used those terms yet, and now we are. Example number 1, you will write down on your YouTube sheets. Example number 1 says round 7 6/10 or 7.6 to the nearest whole number. Okay, I'm going to draw. I guess I'm going to leave my number line up for now. 7.5 obviously lies directly in the middle of 7 and 8. We need to determine whether 7.6 or 7 6/10 is closer to 8 or closer to 7. Again, you can find 7.1, 0.2, 0.3, 0.4, 5, 0.6, 0.7, 0.8, 0.9. You can find it on a number line and understand that 7 6/10 is closer to 8 than it is to 7. You can also see the number 7 6/10, and you can look at the tenths place and you can determine whether or not you want to round up or down. Well, we know that when we have 5, 6, 7, 8, or 9, we round up, and when we have a number lower than 5, we round down. So this 6 tells me that I need to round up to the whole number 8. And that's your answer for example number 2. Or sorry, example number 1. Example number 2 says, estimate the product of 8 and 7/800ths, the product, and 6 and 1200ths. Okay, so we need to determine whether we want to round up or down before we multiply. 8 and 7/800ths. This 7 tells me that I need to round up. It's equal to or greater than 5, so I round up to 9. Alright, and we have 6 and 1200ths. This 1 also tells me to round, it tells me to round down because it's less than 5. So I will round 6 and 1200ths down to 6, and I will multiply because it asks me to estimate the product of 8 and 7/800ths and 6 and 1200ths. I multiply 9 times 6. My estimation is 54. And that's your answer for example number 2. Example number 2 is 54. Example 3, found on page 681, it says, Vera has a flower and vegetable garden in her backyard. This rectangle represents the dimensions of her garden. What is a reasonable estimate of the area? I have 12 and 2/10 meters, and I have 7 and 8/10 meters. So first, we have to figure out, I guess first I'm going to write down the formula for area, which is length times width. I know that I need to multiply my length by my width to find out the area of this garden. So first we need to round. This 2 is, of course, smaller than 5, so I round down to 12. This 8 is greater than 5, or equal to 5, so it tells me to round up. So down to 7 or up to 8, this 8 tells me to round up to 8. I multiplied those two numbers because my formula for area is length times width. I'm multiplying the estimated length by the estimated width, and I will get 8 times 2 is 16, 8 times 1 is 8, plus 1 is 9. Okay, so my estimated area of this garden is 96 meters squared. And again, you can also write 96 square meters if you'd like to write it that way. And this is your answer for example number 3. Okay, example 4. Example 4 is the stop sign found on page 681. A stop sign is an example of a regular polygon. All the sides of the regular polygons have the same measure. Okay, they drew their stop sign. Let's see if I have one in here. Nope. So I'll have to draw my own. Stop sign is an octagon. It has 8 sides. 2, 3, 4, 5, 6, 7, and 8. Alright, and it says that each side is 31 and 75 hundredths centimeters. What is a reasonable estimate for the perimeter of this sign? Because there are 8 sides, and this is a regular polygon, every side is the exact same length. So the perimeter of an octagon will equal 8 times, I'm going to write S, that represents the side. 8 times a side, you only have to multiply it by one of them. Okay, now if I wanted to find the exact perimeter, I would take 8 sides multiplied by one of the sides, 31 and 75 hundredths centimeters. But because I don't need the exact, I can round. So I'm going to round to the nearest 1. And this 7 is greater than 5, so I round up to 32. I don't round down to 31. So I'm going to write 32 multiplied by 8 sides. The approximate perimeter of this octagon is times 3 is 24, 25. The approximate distance around the outside of this octagon is 256 centimeters. And that again is an estimate. It's not an exact number because we rounded 1 and 75 hundredths up to 2. Alright. Turn the page. We have one more example that we'll cover. Example number 5. It says the interior dimensions of a personal storage space are shown in this diagram. What is the approximate volume of the storage space in cubic meters? Okay, first I'm going to draw our shape. Okay, it looks like it's a rectangular solid. Okay, the length on the bottom is 2 and 84 hundredths meters. The depth is 3 and 4 hundredths meters, and then the height or the width is 2 and 69 hundredths meters. Now again, it asked us for an estimate, so we need to round each one of these to the nearest 1. We're going to round the ones place. I'll shrink that down a little bit so we can work. Okay, I'm going to round first the width. 2 and 69 hundredths. The 6 tells me that I need to round up to 3. The formula for volume I'll write at the top. volume equals length times width times depth. The depth of your object. Oop. Forgot to do that. Okay, so my estimated width is 3 meters. My estimated depth, 3 4/4. I can round down to 3. The estimated length of my object, 2 84/100 meters. This 8 tells me to round up to 3. So I'm just multiplying length times width times 3. The estimated length, 3 times 3 times 3. Width, length, and depth. 3 times 3 is 9. 9 times 3 is 27 meters. My label it's not finished with meters because I'm not just measuring length. I'm measuring volume, so I need to label it meters cubed. Okay, again, these are estimates. I estimated, first I rounded to the nearest one for the length, depth, and width. Then I multiplied those 3 estimates together, and I came up with 27 meters cubed. Double check my answers. Perfect. 27 cubic meters is another way that you can write that, of course. We'll go over a few of the practice problems tomorrow. We got 5 examples written down on the board. This is example number 5. So if you have any questions, please bring them tomorrow, and I will try to answer them then. Have a good night, and I'll see you then.